Hi, fifth graders. Welcome to Mrs. Grosland, Sir Isaac Newton's tricks. Okay, on the floor I have two eggs, egg 1 and egg 2, and I want you to watch what happens when I spin and stop them. Here goes the first egg. Well, that's weird, it didn't stop. Let's try that again. Spin it really hard, and it just keeps going. All right, let's try egg 2. Ooh, that really spins. And I stopped it right away. Third try. Stops right away. This one keeps spinning. And I'm wondering if you know why. So they're both two white eggs, both from the same egg carton. One looks like it's a little bit bigger than the other, but it's not the size. The reason why one of them spins a little bit longer than the other one is that one of them is hard-boiled and the other one is not boiled at all, it's raw. So number 1 is the raw egg, and it keeps going because of the yolk inside. The yolk inside the egg is in motion and it wants to stay in motion. So even though I've stopped the egg, the inside of the egg is still going. Okay, so that first one was an example of Newton's first law, which is an object in motion stays in motion, an object at rest stays at rest unless acted upon by an unbalanced force. Here's another one. Maybe you have seen this one before. This one is called a Newton's cradle. And watch what happens. There's 5 balls, and I'm going to set it going here. And it's kind of quivering here, but so when you started one ball went back and forth. Watch what happens when I do 2. 2 balls go back and forth. When I do 3, 3 balls go back and forth. And I can keep going. I'll try 4. So which of Sir Isaac Newton's laws does this exemplify? Which is an example of? And if you said the third one, for every action, there's an equal and opposite reaction, you are correct. Because when one ball went on one side, the other ball went on the other side. For every action, there's an equal and opposite reaction. All right, this is the last experiment I'm going to show you. And you could try this at your house if you want to, with your mom and dad's permission. I would suggest that you start with a towel underneath what you have. I have an ordinary glass of water. Probably have it fuller than I need. A pie pan. And I'm centering that pie pan right over the glass of water. And then I'm going to take a toilet paper tube, just an empty toilet paper tube. By the way, you can get toilet paper at Walmart sometimes if you time it right. I'm going to tip this up just a little bit more so you can see the top. And it's important to get that toilet paper tube right over the center of your glass. And I'm using egg number 1, if you recall. I don't know if we can spin it here. Egg number 1 is the one that continues moving because it was the one that is raw. So I'm being very brave. And I'm going to put my egg right here, balancing right on top. And I want you to watch what happens. I'm going to hit this pie pan. And I want you to watch what happens to the egg. Okay? Ready, set, go. Okay? I didn't spill any water. Okay? I don't know if you noticed what happened or not. I have this glass too full. It's spilling water on my towel. Good thing I got the towel down, right? I'm going to try it again. dry my egg off a little bit. And I want you to keep an eye on that egg and see what it does. So now that you know what happens, you know that the pie pan goes flying. And kind of going with it goes toilet paper tube. Like this. And then the egg can go either up this way. I had it this way, which is maybe a little bit more daring because it doesn't stay very well that way. And again, I'm a little bit off here. You got to make sure that you center it, because if you don't center it right, the egg hits the side of the glass and then sometimes it breaks. Okay, my pie pan is not totally flat. It's kind of wobbly. I don't know if you can see that on the camera or not. All right, so again, I'm going to hit it, and you can hit it as hard as you want or as light as you want. And I bet you're wishing that I hit it as hard as I could. And it kind of scares me to do it, but I'm going to do it. I'm going to go really fast and really hard. I'm going to use a lot of force, and I'm going to use a lot of acceleration. Ready? 1, 2, 3, go. All right. Same thing happened. So which of Sir Isaac Newton's laws did we use there? I got a crack in my egg. I don't know if you can see that or not. So you might have thought force is mass times acceleration, but it really doesn't matter how hard or how light. Let's see if I can do this one more time before the egg cracks. It's not force equals mass times acceleration. If you watch the egg very carefully, again, making sure that you've got it centered. I don't think I'm centered here. All right, here we go, and I'm just going to lightly tap it. Same thing happened, okay? So it's not force equals mass times acceleration. It is this same one that we had before. An object in motion stays in motion. An object at rest stays at rest unless acted upon by an unbalanced force. Okay, well, I was the unbalanced force. I was the one that hit the pie pan, okay? And the pie pan went flying, the tube went flying, but the egg, if you go back and rewind it, you could almost see the egg almost hovering here. The egg is at rest, and it wants to stay at rest, and it will unless it's acted upon by the unbalanced force. The egg dropped because of gravity. So it wanted to stay where it was, but gravity made it fall in there. Okay? So again, if you're going to try this with your family, make sure it's okay with your mom and dad. I guess you could probably do it with a hard-boiled egg so you'd have less mess. But so see how much water I have in there. Let me start with the egg out so you can see how much water I have in there. I wouldn't go any less than that because the egg will hit the bottom and will crack. And at the very beginning, I had it up a little bit higher, and I thought it would splash, but it really didn't. So even a little bit higher than what I have it would work. So kind of an amazing trick. Again, an object in motion stays in motion. An object at rest stays at rest. Have a good day.